Alright guys, today we're going to use something called the discriminant to determine how many and what types of solutions there are to a quadratic. So what we looked at, if you remember this from a long time ago, we had linear equations whose solutions were, oftentimes we got one solution, but sometimes we got either identity, which meant there were many, in fact infinitely many possible solutions, or we got no solution at all, which meant you just couldn't solve the problem at all. With quadratics, we have a couple different issues. The issues that we have are, first off, there's usually not just one solution, there are two. But there are certain situations in which we can get one or zero solutions. So what we're trying to do is figure out, okay, not only what kinds of solutions are we going to have, but even, to a certain extent, what are they going to look like? So here's what you need to do. As a quick review, I want you to complete each of these three problems using the quadratic formula. All of them are already set equal to 0, so you don't have to worry about that. Just use the quadratic formula and give the answer or answers to the problem. If you get a decimal, you can just round to 2 decimal places. Pause and then come back. Okay, so taking a look, this first one, our A is 1, our B is 3, and our C is -4. We are going to write the opposite of B, plus or minus the square root of B squared. Again, I like to square before I put it in there. That prevents me from making any silly sign errors. So that's 9 minus 4 times A is 1 times C is -4. All divided by 2 times 1. So simplifying that, 4 times 4 is 16, so since I've got two negatives, this is going to end up being plus 16. 9 plus 16 is 25. And 2 times 1 is 2. I'm going to do that too. So I'm going to split up into two answers now, -3 plus 5 over 2. And -3 minus 5 over 2. I get 2 over 2, which is 1, and I get -8 over 2, which is -4. Okay, so for this first one, I got two answers, and they looked, I don't know, pretty darn nice. Okay, for the next one, I get A is 2, B is -3, C is 17. Plug in the opposite of B, so the opposite of -3 is 3, plus or minus the square root of still 9. -3 squared is 9, minus 4 times 2 times 17. That's not a negative. All over 2 times 2. Simplifying underneath the square root, 9 minus 4 times 2 times 17 is -127. We cannot take the square root of -127 without using imaginary numbers. We haven't used that yet, so for right now we're just going to simply say that this is no solution. I'm going to use NS as a nice little abbreviation there. Okay, and the last one is going to be a little bit different than the first two. Here, our A is 3, our B is 10, and our C is -1. Plop them into the quadratic formula. Opposite of B, plus or minus the square root of B squared is 100, minus 4 times 3 times -1. The -1 is definitely important. All divided by 2 times my A, which is 3. 100 minus 4 times 3 times -1 is 112, I believe. And here's where this one gets a little bit tricky. We don't really have a square root of 112, so we're just going to have to kind of figure that out. It's 10.58. So our two answers are going to be -10 plus 10.58 over 6 and -10 minus 10.58 all over 6. This first one is just simply 0.58 divided by 6, or right about 0.097, or maybe right around, it's very darn close to 1/10, okay? And this one is negative 20.58 divided by 6, and that's negative 3.43. Now, what we know is on those last two answers, I kind of want to speak to those really quickly. We know those aren't exact answers there. We rounded. If we weren't to round those, they would have been crazy, messy, ugly decimals. Okay, so I want you to describe the 3 types of answers that we got. There were actually 3 types there. And then what we're going to do is, well, just do that first. Let's just do that first. Think about what those 3 different types of answers were. Okay, so we actually got, I guess you'd call them 2 nice answers. Those were what we call rational answers. That's what we got for the first one. Okay, for the second one, we got none. No answer at all. For the third one, we actually got 2 irrational answers. Irrational numbers are those crazy, wacky decimals that come from numbers that you can't take the square root of most often. So now, what part of the quadratic formula was the one that caused you to have those different types of answers? What made the first 2 answers nice versus no solution in the second one? What was causing that? I get that all of it was working together, but it was this part. The stuff underneath the square root. Okay, that's called the discriminant. B squared minus 4ac, not the actual square root part, just b squared minus 4ac. That's called the discriminant because it discriminates between the different types of answers. It kind of sorts the types of answers for us. So there's actually 4 different types of answers we can get. We figured out 3 of them. We could get 2 rational answers. We could get 2 irrational answers. We could get no solution. And there's actually one other type, which I'm going to have you figure out. So try to think about what type of number would be under the square root for us to get 2 rational versus 2 irrational and versus no solution. Look up if you need to and figure out kind of why that square root allowed us to get nice numbers in the first and not nice later on. Pause and think about it if you need to. Okay, so to get 2 rational, you would need a positive perfect square underneath the radical. Like in that first example, we had a number underneath the root that when we took the square root of it, we got a whole number. That's why we had nice answers. Okay, because we didn't have to get a crazy weird decimal from our calculator to figure out what the square root was. If it was irrational, we would need a not perfect square. I'm not going to even write it out again. I'm just going to write an arrow up. We would need not a perfect square under there. The no solution one, we needed some kind of negative number. Now, there is actually a 4th choice for the number and types of answers that we can get. The 4th option is 1 rational answer. Think of when we would get 1 answer. It's when we would have, you can pause and think about it if you're trying to guess. It's when we have 0 underneath the square root. Because think about how that would look with the quadratic formula. You'd have negative b plus or minus the square root of 0 all over 2a. Right? So think about what that looks like. You're going to be adding and subtracting a 0. You're going to get the same answer twice. And it's always going to be a nice answer, either a pretty fraction or a whole number, because you're not using any weird decimals there. Okay? So the way you use the discriminant is really easy. If you just want to know what kinds of answers you're going to get, you just figure out what number would be underneath the square root of the quadratic formula. If it's a perfect square, you get 2 rational. If it's not a perfect square but still positive, you get 2 irrational. If it's negative, you can't get an answer because we can't take the square roots of negatives. And if it's 0, you get 1 rational. Okay? So, what I want you to do is figure out how many and what types of solutions each of these quadratic equations have. The thing that you do have to pay attention to, I didn't give you any tricky examples, but you got to make sure before you use the discriminant that your quadratic is equal to 0, because it's part of the quadratic formula, so the same rules apply there. So, go ahead, figure out what types of solutions we get for each of these, pause, and then come back. Okay, so for each of these, all you need to do is calculate what's underneath the square root. So, b squared for this one is 100 minus 4 times 3 times 2. Well, 4 times 3 times 2 is 24. 100 minus 24 is 76. So think about it. If I have a 76 underneath my square root, that does not give me a nice pretty whole number. Since it doesn't give me a nice pretty whole number, it's going to give me 2 irrational solutions. For the next one, b squared is 100 minus 4 times 7 times 5. That's 64 minus 20 times 7 is 140. So we get a negative number. I'm not going to even bother figuring it out. I was going to figure it out, and then I realized I didn't even need to. I guess if we really want to be picky about it, we could actually do it. And it's negative 76. Just funny how I did that. But again, once you see negative, don't even think. Just kind of be like, oh, it's negative. I get no solution. Okay, and C, b squared is 25 minus 4 times 6 times negative 21. Okay, so that negative is going to be really, really, really important there. And we get for that one 529. Now, you may not know off the top of your head whether or not that is a perfect square or not. It is. It's 23 times 23. So since that's a perfect square, we get 2 rational answers. Now, if we'd gotten 0, it would have been 1 rational. Okay? So that's all you're going to be doing is trying to figure out how many solutions we have to a quadratic equation without even doing it. That's it for this one.